Hello, Astro friends, and welcome back to another edition of In the Cosmos from the De Anza College Planetarium. As always, I'm Toshi Komatsu, the director and the host for this program, and in this episode we continue on our mini-series on the moon, this time focusing on the moon and its differing positions in the sky. We'll put a link to part 1 in the description below. Let's start with the Crescent Moon. As before, it's quite low over in the west, just after sunset. It's 9:45 p.m. local time. Now we're going to zoom way out so that we can see the horizon from east to west, and we'll keep the time the same as we shift our view off to the side a little bit here. We'll keep the time the same at 9:45 as we skip several days into the future. Now notice that the trail follows the moon here, indicating the moon moves a little bit every single night against the background stars. This change in position is because the moon is orbiting Earth. Well, let's think about this orbiting motion by modeling it. As usual, we have a moon ball on a stick to represent the moon, and from the vantage point of Earth, which we'll say is the camera, we can see that currently the moon ball is blocking these distant stars, which is represented by my face. But as the moon moves along in its orbit, say to the left here, then we see that at a later point the moon is no longer blocking these distant stars right here. Now the moon is blocking these distant stars, sort of towards the direction of our star projector. Now in Stellarium we saw that trail following the moon, and here we can see that that's a consequence of the moon physically moving in space. Let's view this one more time, but from space. We start off here by looking on June 13th, and right now the moon is in front of the constellation of Cancer the Crab, and the moon is in front of these stars here. 3 days later, though, the moon moves along in its orbit, and then it's in front of Leo the Lion. The moon spends a few days in front of Leo the Lion, until 3 days later, the moon is now in front of Virgo the Maiden here. So again, the moon is continuously moving in its orbit, and from day to day it appears to move against the background stars. It's about 30 days for one orbit, and knowing that a full orbit is 360 degrees, that means that the moon moves about 12 degrees in the sky every single day, and 12 degrees is a little bit more than the width of your fist held at arm's length away. And one last thing. Last month, there was a lunar eclipse, and eclipses, they always come in pairs, so 2 weeks later, there was a solar eclipse. Now don't fret if you missed it. So it turns out you could have only seen this eclipse if you were near the North Pole, as seen in this animated map. Now the gray area that you're seeing here shows the places where you could have seen a partial eclipse, and the red dot that we'll see as it starts up again here is the path of the greatest eclipse, which started in northern Canada, reached Greenland, and also Russia. If you had seen this eclipse, you would have seen a very special kind of solar eclipse, an annular eclipse. Annular means ring, and you can see in this animation why it's called that. It turns out that in this case, the moon was a little bit farther from Earth than usual, making it appear a little bit smaller than usual, and it was unable to completely block the sun. So we get a ring of sunlight surrounding the moon. Well, that's it for this episode. Next time we'll continue looking at the moon's path across the sky, but then we'll start putting some limits on that path. Until next time, go ahead and please like and subscribe and share this video. Also, keep an eye on all of our social media. Those links will be in the description below. And as always, this is the De Anza College Planetarium wishing you clear dark skies and signing off for now.